looking at 9.1 homework, and we're doing C. Okay, 1C. Now remember, if there were just 10 kids, it would be 10 factorial, right? That's question A. Just take all these people and line it up in rows. But if the boys have to sit together, then you've got this clump of boys. They're inseparable. They're like tied together. And then you've got 4 girls. So 4 single people, right? So it could be girl, girl, clump of boys, girl, girl. It could be girl, clump of boys, girl, girl, girl. We want to know how many ways we can arrange that. This is like bundling the books on the shelf. How many things am I really arranging? My 4 girls and my clump? 5. So start with 5 factorial. But any bundle has to be multiplied by the bundle factorial. So there's 6 boys. I know, 4 boys. Wait, I got this wrong. 4 boys and 6 girls. Sorry about that. So 4 boys and 6 girls. So it's going to start out with 7 factorial because there's 6 girls and then this bundle of 4 boys. But when I tie them together, how many ways can I arrange 4 boys? 4 factorial. So this is the total. Start with the total. You're arranging 7 things. 6 girls, not together. It doesn't say the girls have to be together. The girls can be anywhere, but the boys have to be together. So that's 7 things. And then those 4 guys can be arranged this many ways. So that's the answer to the question, sir.
So then, will that be how like all of those type of questions are worded? Because I like read it as like we're like getting rid of the not getting rid of the girls, but we're like ignoring the girls and we're only like lining up the boys.
Well, the question is an extension of the original sentence.
Okay.
So in how many ways can 4 boys and 6 girls be lined up in a row with all the boys together?
Okay.
So yeah, I'm gonna read the whole question. All right, anything else from this 9.1 homework? Kylie? Loud, honey.
1B.
I couldn't hear you.
1B.
B? In a circle, how many ways can you put 10 people in a circle?
9
9 factorial. Period. It doesn't matter if they're boys, girls, bears, squirrels. If there's 9 or 10 of them and we're putting them in a circle, it's going to be 9 factorial.
Can you do 1D?
In a row with a girl on each end. So the only rule is I have to have a girl on each end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So who has to sit here? How many girls do I have to choose from? 6. Right? So I put a girl there to make sure I have a girl on that end. Now I'm going to come down and put one down here. How many do I have to choose from down there? 5. Now how many people are left? Now these are not people. This is choices. There are 6 girls. And I snag one and put her here. Snag another one and put her here. How many kids are left
8.
to start filling in?
8.
8, 7, won't this be 8 factorial? Yep, that's it. So it's 6 times 5 times 8 factorial. Emma?
Could you do number 2?
Fighting Irish? Okay, well the first thing I have to do is what?
Count the letters.
Count the letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You get 13? So I'm going to start with 13 factorial. That's the beginning of everything. Now, it turns out in this word that we have 2 G's. Oops. So 2 factorial for the G's. What else? We've got 3 I's. Oh, 4 I's. 1, 2, 3, 4, right? 4 I's.
2 H's.
Got an H here and an H here. F, T, N, R, S. So that's it. And then when I type this in, Emma, I have to do it carefully separately because 13 factorial has to be divided by every single one of those. So you're either gonna have to put that in parentheses, or what I do when I type it in, I do 13 factorial divided by 2 factorial equals, divided by 4 factorial equals, divided by 2 factorial equals. So I do each division separately. If you do it at once, it's got to be parentheses. All right, one more. Who else has a question from that?
3A.
3A, how many different, there are 8 boys and 6 girls. And I am picking 2 of these and 2 of these. Anytime I have a big group, and I'm picking a few out of the group, it's either a P problem or a C problem. So it's either gonna be 8C2, there's 8 boys, I'm picking 2 of them, or it's gonna be 8P2. Anytime you're picking a few out of the many, it's a P or a C. Okay? Now, what do you think? Is this gonna be a P or a C? C. I'm picking a committee or something, a club or something, so I don't care who gets picked first. You don't care, you just want to be picked, right? So this is gonna be 8C2 times 6C2. It's times because I am picking boys and girls. If I were picking boys or girls, it would be add. Or is an add. And is it times. All right, let's put those away. Let's get our notes out. Finish up this that we have left to do. So yesterday, before we got interrupted for those silly caps and gowns, by the way, don't lose yours.
You get people actually use them.
Well, what gets lost usually is hats. Hats and tassels come up the same. All right, oops, there's no fraction. All right, so I had told you yesterday, right, this is my problem, but I had told you yesterday that this notation means the same as this. Okay? I'd also told you, and I use numbers because these letters get confusing, if you had 7C5, the by hand formula, you would never do this with your calculator, because your calculator will just do that. But if you have to do it by hand, like I did back in the olden days, it's 7 factorial over 5 factorial, 2 factorial. 7, 5, and 7 minus 5. Remember that from yesterday? So, what is this? It would be n factorial over r factorial, and then n minus r factorial, because it's this number factorial over this number factorial, and also over the subtraction factorial. So what would this one be? N factorial over n minus r factorial. And then how do I get this last piece? I have to subtract these. So n minus r, what does that end up equaling? Just r? Are they the same thing? Your job was to show they were equal. Are they equal? Yeah, it's the same thing, just backwards of each other. And what that means is, and I don't know if you thought about this or not, but take your calculators out, please. What's 10C3? Just figure out what that is on your calculator for me. 10C3. 120. Okay, now do 10C7. Why are they the same? because this would be n factorial, 10 factorial over 3 factorial, 7 factorial. And this would be 10 factorial over 7 factorial, 3 factorial. Now that makes sense. Imagine that there are 10 kids in the room. And I'm gonna pick 7 of them to take on the field trip. By choosing that group of 7 and taking them out the door on the bus, what have I automatically done with the other 3?
Left them.
I've chosen them, I grouped them together, right? So if you have 10 people, or 10 somethings, there are exactly the same number of ways to group them 3 at a time as there are to group them 7 at a time. Because the act of grouping the 7 automatically groups the other 3. You got the chosen and the unchosen. You notice that in Pascal's triangle? Have you noticed the symmetry here? Let's look at the extra 1, 5, 10, 10, 5, 1. Have you noticed the symmetry? That's because 5C4 is the same as 5C1. There'll always be that symmetry. Okay, next one. You guys look like you are so out of it. Have you had a hard day?
Yes.
I am so sorry. Oh, by the way, those of you who haven't yet seen the musical need to go.
So good.
It is very interesting and entertaining. I will say that I do not understand everything that's happening in there, but it was definitely made me chuckle a few times, and we have a number of students in here who participated and did a wonderful job. So go if you can, it's free. Except you have to get your tickets on your phone. So of course, who's having a hard time with that, needing help and all that, but I finally got it done, so I got through it.
Roll out the red carpet for you.
They don't, they say, here's that old woman coming down here. Why can't you figure this out? All right, here we go. What's this? Go ahead, you know this one, this was easy. What's this one gonna be? N factorial over 2 factorial n minus 2 factorial. If it's easier for you to think of it like this, think of it like that. That's what it is. You gotta know this little formula. N factorial over 2 factorial over the subtraction factorial. Now, what's this one? Don't let the letters bother you. What's on top?
N plus 1.
N plus 1 factorial. On the bottom, we're gonna have a 2. What else are we gonna have on the bottom?
N plus 1 minus 2.
N plus 1 minus 2 factorial, which we can simplify to just n minus 1 factorial. Now, I'm supposed to be able to add those together. Well, before I start getting the common denominator, let's talk about this for a moment. What does n factorial mean?
Any number
N times
n
n minus 1, I heard somebody say it, good job, times n minus 2, n minus 3, forever and ever and ever, right? That's n factorial. 5 times 4 times 3 times 2, on and on. All right, now I got a 2 times 1. What's n minus 2 factorial? N minus 2, n minus 3, dot, dot, dot. Remember, a factorial starts with whatever it is. So 8 factorial starts with 8. So n minus 2 factorial starts with n minus 2, and then goes down by ones. Well, what happens in that?
They cancel.
All of this cancels, and I have left n squared minus n over 2. That's all that's left right here. I just simplified that one. Now let's do the same thing with this one. All right, so what's the numerator?
N plus 1.
N plus 1.
N plus 2. N plus 3.
No, we're not going up. We're going down. So you don't add. You go from 5 to 4 to 3. So what comes after n plus 1?
N plus 0.
N, yeah, N plus 0 or just N. And then comes
And minus one.
N minus 1, N minus 2, and so on. Now, does that make sense to everybody? Remember, factorials count down. So minus 1, minus 1, minus 1. Over 2 times 1. And then what's N minus 1 factorial? N minus 1, N minus 2, dot, dot, dot. Again, all that cancels. So from my first fraction, I had n squared minus n over 2. From my second fraction, adding them together, I have n squared plus n over 2.
Yes.
Well, I thought I was going to have to get a common denominator, but I already have it. So what happens when I add these together?
2n squared.
2n squared over 2, which is just n squared.
And then when you're counting it out, where did 2 times 1 come from?
2 factorial. In the denominator, I did 2 factorial. So if that had been a 3 factorial, it'd be 3 times 2 times 1. All right, now we're talking about probability. We talked about that yesterday in terms of binomial. Let's do a quick review problem. Let's say we're gonna flip a coin 8 times. What's the probability of exactly 6 heads? So you know, flip a coin.
Yes.
So we're gonna start with 8 C6. Now the reason it's a C, guys, is, do I care which flips were heads? No, so I don't care what the order is. It could be head, head, tail, tail, head, head. It could be any combination of that, right? So I just want 6 of them to be H's. Now, the probability of getting a head is, flip a coin, 1/2. Don't overthink it, folks. Flip a coin. What's the probability of getting a head? 50-50. So you can put 50% if you want 0.5. And then how about a tail?
50%.
1/2 or 0.5 again. And in this particular problem, we want 6 heads and 2 tails. So the answer to the problem would be all of this times each other. I got 0.1094. It isn't. It's a review question from yesterday. I said that, but you know, who knows what you were dreaming about. Just wanted to get us back in the groove of probability. And that's all we're gonna do the rest of the year. Actually, the whole rest of this unit. That's all we're gonna do. Till we get to sequences and series, okay? So here we go. Here we go. Maggie has a oh wait, up at the top, definition, probability versus odds. Does anybody know the mathematical definition of either one of those? They are not the same. Sometimes the guys on the street will say, oh, the odds of me getting that. Well, odds is very different than probability. Does anybody know the difference or know what either one of them is? What do we mean by probability? When you told me the probability of heads was 1/2, where did those numbers come from?
How often they were caught?
Well, there's 1 head on the coin, and there's 2 total faces. So probability is, we call it success over total. Now, by success, we mean what you want. So if you want heads, there's one head, and there are 2 total faces. If you were rolling a die, probability of getting a 3 is 1/6, because there's 1 3, and there's 6 total faces. That's probability. Odds is success over failure. So in other words, if the probability is 1/6, Dave Jones, what are you doing?
Sorry.
No, it takes more than I'm sorry. That is not right. You cannot do that. Do you see these wrinkles and this gray hair? I'm not kidding. It's that kind of crap that just pushes me over the edge. Don't do that. It's so rude. Success over failure. If the probability is 1/6, then the odds would be 1 to 5. We normally write it like that. The fraction form would be 1/5, but odds are usually written this way. Anybody ever watch the Kentucky Derby? It's coming up. Okay? And they post the odds of the horses. This is what you see. You see it written this way. That's the way odds are posted. So what this means right here is, if they ran that race 6 times, he'd win 1 out of those and lose 5 out of those. That means his probability of winning is 1/5. When you see a horse that's got odds of 10 to 1, bet on him. Because what does that mean? If they ran 11 races, he'd win 10 of them, right? Huh? Okay. Now, this is, I said bet on him because he's probably gonna win, but this isn't where you make your money. Where you make your money is on this horse, because nobody's expecting him to win, and when you place your bet, you'll win a lot, if he wins. All right, so that's the difference between probability and odds, okay? All right, now, Maggie and Elizabeth have a bag of M&Ms. They have gone through their bag of M&Ms, and they have counted how many they have of each color. So, for example, Maggie has decided that 30% of her M&Ms are green, and so on. Elizabeth has decided that 20% of hers are green. So do you understand the table? Okay. Notice that the numbers in each girl's table add up to what? Why? 100%. Any probability problem, the total probability has to be 100%, right? So the total for the whole bag has to be 100%. All right, let's choose a candy from Elizabeth's bag. What's the probability it will be green? 0.2. Not hard. 0.2. I got a 20% chance of getting green if 20% of the M&Ms are green, right? How about for Maggie's bag? Not yellow. 0.8. Because 20% of Maggie's are yellow, so the other 80% will not be yellow. Candy's chosen from each bag. What is the probability that they will both be red? So in other words, I want to get a red one from Maggie, and I want to get a red one from Elizabeth. Well, what's Maggie's red? 0.2. What's Elizabeth's red? 0.3. When I am picking a red and a red, what do? Multiply. So the answer is 0.06. You'll have a calculator when you do all of these problems. So if you're at all uncomfortable with the decimals, fractions, or percents, please type it in on your calculator. This is not 0.6, it's 0.06, right? There's a huge difference. All right, candy's chosen from each bag. Probability that neither will be brown. So not brown and not brown.
0.2 times 0.1, 0.02.
Watch it.
0.8.
Not brown. Not brown.
0.8 times 0.9.
0.8 times 0.9.
Yeah.
0.72. We have to read very carefully. All these problems are word problems, so you have to read very carefully. Is everybody okay with that one? All right, candy chosen for each bag, what's the probability that the first one will be green and the second one will be blue?
0.3
So
times
I
0.2.
want green and blue in that order. I gotta get green first, so green out of Maggie would be
0.3.
0.3. And blue out of Elizabeth would be
0.2.
0.2. Did you get 0.06? All right, would you do F? What's happening here, Bill?
Sorry.
Yeah, go across. Where do you go speak?
We're going to.
That's not the answer to my question. Where are you supposed to be? Okay, go downstairs and go to religion then. Thank you. What is happening with this one? All right. So tell me what you came up with. It says we gotta have a blue one and a green one. So what did you come up with? 0.1 times 0.2. Did you come up with 0.02? Now, did anyone stop there? Or did anyone go on from there? Is a better question. Jeff?
Well, I was just confused because it doesn't say like specifically like which bag it comes with.
Exactly. That makes a huge difference. This question doesn't say it has to be blue and then green. Could it also be green and then blue? Would that satisfy the problem? So you gotta do that case too. So what is green and then blue? 0.06? And then we're gonna add those together because it's a this or this situation. So it, like Jeff said, it doesn't say, the other one said, this first, then this. This one doesn't say that. This just says I wanna have one of each, right? So I gotta get blue and green, or I gotta get green and blue, either one. So my answer is 0.08. I need everybody to eyeball question E and question F and make sure you see the difference. All right, I'm taking one from each bag. What's the probability that neither will be red? Neither will be red.
0.8 times 0.6. 0.7.
Yep, 0.56. All right, now we're gonna do some card problems. To do this problem, yep,
Can we write them as percentages?
yep, you can absolutely write them as percentage, so 56% would be fine. When you do probability, you can write them as percents, decimals, or fractions, whatever is easiest for you to process, okay? The only thing about fractions is they gotta be reduced, lowest terms, if you're gonna write your answers. Okay? Now, anytime you do basic probability, you gotta know about a deck of cards. There's a whole page of card problems here. So tell me about a deck of cards. What are the basics I need to know? So there's how many cards? 52. They're divided up into four suits: hearts, diamonds, clubs, spades, right? 2 of those are red and 2 of them are black. So half the deck, 26 cards, is red. Half the deck, 26 cards, is black. Each suit, so the diamonds, for example, are composed of 13 different cards, right?
Yes.
Ranging from an ace all the way, so you got ace, which is like a 1, right? One little diamond or something on it. And then you got a 2, 3, 4, all the way up to 10. Then you have a jack, queen, and a king, which are cards that have faces on them, so they are called face cards. And there's those in diamonds and clubs and spades and hearts, right? So that's what you need to know. You do not need to know how to play poker, you do not need to know the rules of euchre, you don't need to know anything except the basics of what a deck of cards looks like. If you don't know that, you got the weekend to kind of get yourself up to speed. You can either buy a deck of cards, borrow a deck of cards, get online, but you gotta get familiar with the basics of a deck of cards so that you can answer a question like, A, 2A, how many 5-card hands are possible? Don't overthink this. How many cards did you tell me there were? 52. And I have to pick 5 of them. So I have a big group. I'm picking 5. It's either a P or a C. Which is it? C. I don't care what order I get them. I'm not playing some wacky game. I just want a hand. So that's 52 C5. That's how many hands there are in a deck. 5-card hands. Obviously, if these were 6-card hands, it would be 52 C6. What is the probability of being dealt a hand? This is a 5-card hand now. What is the probability of being dealt a 5-card hand that's all diamonds? Would you agree, this is problem B, would you agree that the denominator is going to be 52 C5?
Yes.
Because in the denominator goes the total. And didn't you tell me that's the total?
Yes.
Okay, Izzy?
I was just gonna say, is it 13 on top?
Well, it's not 13. 13 C5. 13 C5. Because if I want all diamonds, how many diamonds are there to pick from?
13.
13. So here's my pile of diamonds, and I'm going to reach in and grab 13 of them, or 5 of them, I mean, right? So my numerator is 13 C5. All right, let's type that in on our calculator. Nothing fancy. You can literally type it in, 13 math probability C5 divided by 52 math probability C5. This happens all the time. Do you notice the little E on the end?
Yes.
Okay, don't ignore that. That means that your answer is 4.952 times 10 to the negative 4. If you ever write this as your answer, which kids do sometimes because they're not paying attention to the whole thing, I am going to publicly humiliate you. Because 4.9 cannot be the answer to a probability question. The probability has to be a number less than 1. Right? 100%. You can't have 495%. Okay? So pay attention to the whole row. If there's an E on the end, I'm fine with scientific notation, but you gotta write that part in there. This happens a lot with the card problems. Because, well, think about it. All diamonds in a hand, that would be pretty rare, wouldn't it?
Can you just write E negative 4 instead of times 10?
No. No, right, our answer is a real life number. All right, just a few more and then we'll be done. All right, what's the probability? Now notice, all of these problems, the whole page of them, are all 5-card hands from a standard deck. So every time it says, what's the probability, your denominator is going to be that. That is not going to change. If it's 5 cards, that's your total. Now your numerator will change. I want all face cards. Abby?
It'd be 12 C5.
12 C5. And again, those of you that aren't sure about where the 12 came from, get yourself a deck of cards or look at a deck online and you'll see. 4 queens, 4 kings, 4 jacks. 12 faces. Okay, that's going to be even a smaller number.
4.617 times 10 to the negative 6.
I'm almost there, sir. What did you get?
4.617 times 10 to the negative 6.
I got 3.0.
I got 3.047 times 10 to the negative 4.
That's what I got.
Twelve divided by 53,
12 C5. All red. What do you think all red's gonna look like? What's the probability of all red? What's your denominator? 52C5. That isn't gonna change for any of these problems, I don't think. 26 C5? Please don't try to simplify that, it does not. You have to type it in. Now this will be a bigger number. As you know, it's easier to get all red than it is to get all diamonds. I got .025. Did you? Izzy? Because what does factorial mean? This is 26 factorial over 5 factorial, 21 factorial. This is 52. So it's not 26 over 52. It doesn't work that way because of what factorial is.
why wouldn't the answer just be 50%?
I want you to think about that for a second. If I'm dealing with 5 cards and they have to all be red,
Half the deck is red.
okay, but I don't get all red half the time.
Okay.
I get a red half the time, but I don't get 5 reds half the
Okay.
time. Does that make sense to you? Think about it. I mean, deal yourself 5 cards. You're not gonna get all red very often.
Right.
All right. 3 jacks and 2 kings. So this is problem E. Denominator's 52C5. I want 3 jacks and 2 kings.
When you 4C3 times 4C2.
All right, let's talk about that. She said that pretty confidently. I want 3 jacks. How many jacks are in the deck? How many do I want? There you go, 4C3. How many kings are in the deck? 4. How many do I want? 2. This is going to be another C1. On your homework, some of you are getting lazy and not typing it in. I want you to type it in. I got 9.234 times 10 to the negative 6. That's really small. All right, F, G, and H, do them on your own, and then I will stop. I promise. F, G, and H. Type them in, get an answer. When I talk about the different answers.
Ace is on Facebook. I don't think Ace is on Facebook. Something stupid.
with 5, because the other card you get.
Ollie, I need you to think about these boxes. You have 4 cards, and you have a hand of 5. Can you ever get that? Ollie,
I could.
that's only 4 aces. It's single player.
Alright, let's see what you came up with. I put my answers up here, but I didn't show my work. How many of you, I'm not saying these are right. This is what I got, but who knows? How many, did anybody else get 0.2534 for that one? That setup was 40 C5 over 52 C5. Where did the 40 come from?
12 minus, please do minus.
There are 12 face cards. So aren't there 40 cards that don't have faces on them? All right. Did anybody else get this? That's the hardest one, I think. How many of you set up problem G like this? Okay, that's exactly, if you didn't start with that, then you're in more trouble than we thought, okay? How many aces are in the deck? 4. And how many of them do you want? 4. So that's 4C4. Those are your aces. This isn't complete though, because how many cards are you supposed to have in your hand? 5. So 4 of them are aces. What's the other one? Not an ace. Well, how many cards are there in the deck that aren't aces? 48. So you want 4 aces and 1 not ace. Those kind of problems always trip us up because they don't mention this problem or this card. You gotta think about it. I need 5 cards. If 4 of them are aces, then the other one can't be an ace. It's gotta be something different. Does that make sense to you? It's tricky, but you haven't seen it yet. All right, last one. I got this answer. Anybody else get this answer? You did? My setup was 4C2, 4C2, 4C1, over 52C5. Anybody have a question about that setup? Where did you put it? No, it's 4 tens. And I need to pick 2 of them. All right, remember you got homework due on Tuesday.